So this unit on trigonometry is going to focus on sine, cosine, and tangent. There's a couple of important things that we need to know about naming a right angle triangle first. Now when working with sine, cosine, and tangent, it's very important that we are working with a right angle triangle. That's number one. Number two is we need to know how to identify the angle of interest. It's going to be one of the two acute angles. Given that you have a 90-degree angle, these two angles here, the remaining angles, have to be acute angles. We have to identify one of them that we're actually working with. The naming of the sides is based on this acute angle that we're actually going to be working with. So, when we talk about angles, we usually use Greek letters. This is theta. Theta is just a Greek letter that we use for an angle, whereas we use A, B, C, and D, etc. for the variables for the sides, and Greek letters for the angles. Now when we're looking at this angle, there are three things we have to name. 1, 2, 3 sides. Now one of them is based on what you've seen already in terms of the Pythagorean theorem. The angle that is opposite the 90-degree angle is your hypotenuse. So that hasn't changed. And no matter which acute angle you look at, the hypotenuse is always the hypotenuse. What changes is based on this little angle. The side that is opposite the angle, over this side here, the one that is not touching, this is referred to as the opposite. The one that is touching the angle, the side that touches the angle that is not the hypotenuse, is referred to as your adjacent. Now if I was looking at the other angle, so if I had the exact same triangle, let's say I can draw it exactly the same, there's our 9 degrees. Now let's say we were looking at this one and we're going to call it alpha, just to give it a different name. It's the other acute angle. Now when we're naming this triangle, the hypotenuse is always going to be the hypotenuse, no matter which angle we're looking at for the acute angles. The opposite now becomes this side down here, because it's opposite the angle that we're looking at. And the adjacent is the side that is touching the angle that is not the hypotenuse. Now when we're working with trig, there are three ratios that we need to know. There is a sine, cosine, and tangent. Sine, written short S-I-N, not pronounced sin, it's sine. The actual way that you write it is S-I-N-E, so that's sine. Cosine, short is C-O-S. And tangent, and again, short form is T-A-N. These are the three ratios that we're going to be looking at. Again, based on an angle, and it is an acute angle. Okay. Cosine is also based on an acute angle. Tangent is also based on an acute angle. Sine has a ratio between two of the side lengths, opposite over hypotenuse. Cosine has a ratio of adjacent over hypotenuse. And tangent has a ratio of opposite over adjacent. Now to help you remember this, because you do need to memorize these relationships, this ratio, SOHCAHTOA. SOHCAHTOA will help you remember all of these ratios because it talks about sine is your opposite over hypotenuse, opposite over hypotenuse. Cosine is your adjacent over hypotenuse, adjacent over hypotenuse. And tangent is opposite over adjacent. You need to remember this, so this is one of the easiest ways to help you remember these ratios. Now, what this all means is that when you're given any right angle triangle, first you have to identify your angle. Has to be an acute angle, cannot be the 90-degree angle. So you identify your angle. That's the first step. Once you identify the angle that you're looking at, then you have to label the sides. So hypotenuse, again, doesn't matter which acute angle you use, the hypotenuse is always a hypotenuse. It's opposite the 90-degree angle. Then you need to identify which one is your opposite side. And which one is your adjacent side. So you need to identify those three things as your second step. Identify your sides after you've identified your acute angle. Then you can set up your ratios. Sine of your angle now equals your opposite over your hypotenuse. Cosine of your angle now is your adjacent over your hypotenuse. And tangent of your angle is opposite over adjacent. So if you were given this triangle here, it's a 3, 4, 5 triangle. We know by Pythagorean theorem that 3 squared plus 4 squared equals 5 squared. Now we don't know the angle here, but we're going to set up our ratios. So sine of my acute angle is going to equal my opposite over hypotenuse. So again, I've identified my angle, but I haven't labeled my sides yet. So the second step, based on this acute angle, the hypotenuse is going to be 5, my opposite is going to be 3, and my adjacent is going to be 4. So opposite over hypotenuse, 3 over 5. Now, please keep in mind, this is a ratio. Ratios can be expressed as decimals. So sine of theta is going to be the same thing as 0.6. They mean the same thing. You can always convert a decimal into a fraction and a fraction into a decimal. Cosine of theta is equal to now my adjacent over hypotenuse. My adjacent is 4, my hypotenuse is 5. So I get 4 over 5. Again, decimals can be related as ratios. You can write it like this as well. Tangent of the angle theta is going to be my opposite over adjacent. Opposite is 3, and my adjacent is 4. So these are equivalent. When I say ratio, you can write it as a decimal, you can write it as a fraction. It's easier to leave it just as a fraction rather than having to calculate it back into a decimal, but when you're working with your calculator, it gives it to you in decimal format. So just something to consider. So now we're going to look at how to use your calculator to help you find some of these ratios and to work forward and backwards. So now I'm asking you to find the ratio of sine of 74 degrees. Now, you're going to use your calculator for this, and there's a couple of things you need to know first. The big thing up here is you must be in degree mode. Degree mode, if you go to your mode button, by default, it goes to this mode here called radian. You need to convert your graphing calculator into degree mode. So move your cursor down so it's flashy on top of radian, move it over to degree, hit enter. It will then highlight degree. Once you are in degree mode, we can then do these calculations because we're working in degrees. So second quit to get out of your mode. Sine of 74, sine 74 degrees, enter. It will give me a decimal approximation of the ratio. So 0.961 is approximately what you will get here. If we want to do cosine of 24, your ratio is 0.914, let's say. And if we do tan of 35 degrees, you're going to get 0.700. Okay. So that's just using your calculator for a straightforward find the ratio in decimal form for this. Now, here's what's a little bit trickier. When we do not know the angle, but we are given the ratio. When you are given the ratio, you have to use the opposite operation. So sine has an inverse operation. How we write it is we basically go sine inverse, and we switch where the ratio goes and where the angle goes. Same thing here with cos. Because I want to know my angle, I have to use the cos inverse. I switch where the angle and the ratio go, like so. Same thing with tan. Tan inverse, 1.416, and I put my angle. Now I can set it up and solve for my angle. So, again, using our calculator, we need a sine inverse function. So we can't just press sine anymore, because that won't work. It won't give us an angle. We need sine inverse. So if you look above the sine button, in blue, there's sine inverse. Second sine, and we put in 0.421. It will then give us a corresponding angle, so 24.9 degrees. And if we do the same thing for cos, above cos there's a cos inverse button. Second cos, 0.251, and you'll get 75.5 degrees. And again, above tan, there's a tan inverse, so second tan, 1.416, and we get 54.8. Now here's where it becomes important in using sine, cosine, and tangent, is when we actually solve right-angled triangles. Solving a right-angled triangle means that we find all the missing information from the triangle. Every single triangle is going to have 3 angles and 3 sides. So if it helps you, writing out the list of angles you have, sides that you have, will help you figure out what you're missing. And then you can focus on each one step by step. So if you write out a little table like this, you can see what you have and what you don't have. So for the first triangle ABC, we don't have angle A, which right now is written as alpha. So we need that. We have the side AB, that's 10, that's good. We also have the angle C, which is 32. And we have angle B, which is 90. And we don't have BC or AC, so X and Y. So that's what we need to fill in. On the other triangle, XYZ, again, we've got 2 angles here that we don't know, alpha and beta. So angle X and angle Z, we need to find. Angle Y is 90 degrees. XY is 9, YZ is 10, and we need to figure out what XZ is. So that's setting it up. There'll always be 3 things given and 3 unknowns. So we're going to look at triangle ABC and start solving this one. Now, one of the nice properties that you know about right-angled triangles is that all the angles add up to 180 degrees. So we can easily find angle A by going 180 minus 90 minus 32. So you're going to get 58 degrees. So we solved one of them already. Now, when you're solving the rest of the triangle, use what is given, not what you've solved. If you made a mistake on 58 degrees, the rest of your calculations are incorrect. So now we're going to use 32 degrees, and we're going to label the sides. We have hypotenuse, we have an opposite, and we have an adjacent. So to look at this, we're going to use SOHCAHTOA. For BC, we use what is given, an opposite side, and an unknown, which is adjacent. So that uses tan. You can do all your work algebraically and solve for that side of being 16. When you look at AC, we have an opposite, and we want the hypotenuse. So that's going to be sine. So we set up our sine ratios, and we solve for the missing side to get this. I would like you to try this example and have it ready for class.